Hey everybody, Mr. Fortin here, filming this video for this algebra review to help you a little bit with what we did in class today, which was multiplying square roots. Okay, what else we did there? We expanded and simplified square roots. That's kind of what you're doing on this assignment. And then the last thing was rationalizing denominators. So I'm not allowed to have a square root in the denominator. It's just kind of a math rule, okay? Because then I have an irrational number dividing into something, and there's never a remainder because of that way that rational numbers work. Anyways, also too, if we know how to simplify something like this, we get it in kind of a uniform way. So anyways, looking into this here, getting started with it, I'll just go ahead and do the first one here. Hey, this one's pretty easy. It's pretty easy if you have the perfect squares memorized. So here I have 81. You might think, well, 2 doesn't go into that. Does 3 go into that? It does 27 times, but 3 also goes into 27. Okay, it goes into it 9 times. Okay, so anyways, various ways to get there depending upon how quickly you want to do it. The fastest way to do it is just to have it memorized that 9 times 9 is 81, right? Multiplication table is critical, right? Critical for your success in high school math. So if I know that 81 is 9 times 9 on a multiplication table, okay, then I would know that 9 times 9, right? Then I would know that 9 squared, okay, could replace 81 here, okay? Now I have the square root, okay? So what is the square root of 9 squared, okay? Well, a square root just cancels the squaring, okay? So my answer here is simply just 9. The square root of 81 is 9. You get on the calculator, you're good to go, okay? But you're not using the calculators on the rest of this here, okay? Square root of 0, well, that one's pretty easy because what number squared, right? What number times itself would be 0? Well, that would be 0, okay, right? 0 squared. 0 times 0 is 0. Anything times 0 is 0. So if I take the square root of 0 squared, okay, I get 0 as my answer, right? So the square root of 0 is actually 0, okay? Next up here, number 3, this is where this sort of comes into play with what we're doing in class, where I have 24 here. That's a kind of a big number, okay? So I want to get what's inside the square root symbol to be as small kind of as it possibly could be. Okay, and 24 is bigger than a lot of those that we have in the examples. So I want to get rid of the 24 and get it with something else. So this is that rule, again, kind of the reverse of that rule that we talked about in class yesterday, that if I have a radical, okay, here, and another radical here, okay, I can multiply my radicands and it would equal the radical of the product of those radicands. It just kind of works here, okay? So if this is 4 here, and this is 9, the square root of 4 is 2. The square root of 9 is 3. Okay, and 4 times 9 is 36. Okay, the square root of 36 is 6. 2 times 3 is 6. It just works, right? It's a law we follow. So here we're looking at the backwards here, right? When you have something just like 24, you want to change it so that you get some factors in there that you can simplify. You can take the square root of, okay? So one of the things that might jump out to you, okay, is that I can take the square, this has a 4 in it, I can take the square root of 4, right? Can I? You take the square root of 4, do it with your calculator. Okay, just do it with common sense. Okay, like the square root problems are very common sensey problems. Square root is simply what number times itself is 4. Well, it's 2, right? 2 times 2 is equal to 4. Okay, so 24 can be rewritten in terms of its factors. 4 times by 6. Okay, I can't take the square root of 6. No. And I could break that up into 2 times 3, but why would I? Can't take the square root of 2, can't take the square root of 3 here. So my answer to this is I'm going to take the square root of that 4, and my answer is going to be 2 root 3. That's my answer to number 3. Okay? Number 4 is the same principle, okay, that any number squared gets canceled by a square root. Okay? A square root is simply what number times itself equals that. So anyways, the square root undoes the squaring, right? It's the opposite of squaring something. Okay, that's something that got to commit to that in the notation of math. Okay, so my answer here is just 13. If I squared 13, I get 169. Okay, and what 2 numbers multiply to themselves become 169? Well, 13 times 13, or what 1 number multiplied to itself gets us there. Okay, so get this. Oh, this is easy. Oh, it's easy at the beginning, guys. You're thinking, whoa, am I overthinking this? No. Okay, so this one here, a little more fun. Okay, break it down. Okay, I'm going to get, I notice here, ooh, 600. Well, that's nice because 100, okay, times by root 6. That could be one way I could rewrite this. Okay, 100 times root 6. 100 times 6 would be 600. Okay, so root 100 times root 6. It's proven for us based on this rule, right? This rule of a law of multiplying radicals, okay, that we just talked about briefly in class. It works. You can double check it using some observations. Okay, but anyways, I get this. And this is nice. Why? Well, 100 is a perfect square, right? It's a great number. What times itself is 100? That's right. It's 10. Okay. 100 is the same thing as 10 times 10 or 10 squared. Okay. And the root 6 there, right? I could simplify this a little bit more. I get a prime factorization. I get root 2 times root 3. Well, I can't take the square root of 2. Can't take the square root of 3, but I can take the square root of 10 squared. It is simply just 10. So my answer here is I have 10 root 6s. Okay, so you see it there that the sort of simplification just makes the numbers smaller. Okay, it's easier. We can do more stuff with math if our numbers are small. Okay, 10 times by root 6. Well, I don't have to deal with stuff in the hundreds, right? Hundreds places here. Okay, looking at this one here, 25 doesn't go into it. That's a perfect square, right? 5 times 5 is 25. So it's got to be something else. Ooh, neat trick. Oh, you love this trick here. Anytime the digits of any number add up to 9 or a multiple of 9, it's divisible by 9. It is. It is. It's I know that before I became a math teacher. I was like, something we can kind of look at here. So check this out. 245, okay, is the same as the square root of 9 times by, okay, and I got, right, so we'll figure out what I need to multiply to 9 to get to 245, and that would be, ooh, wait a second. No, I typed that in wrong. Swear, this works, okay? 245. Okay, one of its factors is 9, I promise you, because the factor that goes with it is, what the heck happened? Wait a second. 2, oh, okay, wait, 2 plus 4 is 6, plus 5 is 11. Okay, so anyways, now, we'll get to that shortcut in tomorrow in class. I got a good shortcut for you guys. Let me get rid of it. 9 doesn't actually go into it. So, got to be something else that goes into it. 9, 16 wouldn't go into it. 16 is even. 25 does not go into it. So we might even go higher than 25. Okay, so the perfect squares, remember the perfect squares, okay? 5 squared is 25. Okay, 6 squared, well, no, that's not going to help us because 6 times 6 is 36, and 36 is not going to go into an odd number like this. Okay, what about, I think I got it. 7 squared is what? You should know this from the multiplication table. 7 times 7 is 49. And we're looking at this here. Yeah, it's going to go into it. Going to go into it here. How do I know that? Well, 50 times by 5, which is just one more than 49. 50 times by 5 is 250. Okay, so that means 45 times by 5 got to be 5 less than 250. Okay, so I'm going to get square root of 49. Okay, times by the square root of 5. And I can take the square root of 49. Why? That's just 7 times 7 or 7 squared. What does the square root do? It cancels the squaring. So the square root of 49 is 7. And root 5, I can't take the square root of 5. Okay, that is an irrational number. Okay, square root of 5. So I just leave it like that. I don't have to deal with decimals and whatnot. All right, this one up here. Okay, so now we got into something here called rationalizing the denominator. Okay, rationalize the denominator. Here is, we did this one in class, actually. Okay, no, actually, we did this one in class. We can skip that one. Okay, here, yes, a little more harder. Okay, so here. So the problem is I can't, the square root of 24 is some funky number. So if I look at square root of 24 here, take the square root, I get this, no pattern with the, so square 24, take the square root, it's going to be between 4 and 5, pretty close to 5. There it is. 4.89897994. There's a lot of 9s there, but you know, there's no patterns. And 9s over here. There's no patterns. Doesn't terminate. Okay, so square root of 24 is kind of like it's a concept. There's a number that approaches it. Okay, but you know, it's we don't know exactly what irrational numbers actually end up being because the way the numbers work. Okay, 2 numbers that multiply to be not a perfect square. You can't find the exact number. It's a decimal. Okay, so we leave this in the exact form here. Okay, so the problem is I can't have square roots in the denominator. Okay, this is not allowed. Right here, right here, right here, right here. It's all not allowed, and this is going to hold your key to solving these problems quickly and efficiently. Okay, check this one out here. So what I can do with all these problems, what I told you guys in class yesterday is, and today, right, today here, is if I have this expression, root 12 divided by root 24, sure, it equals something, okay? I want to simplify what that means, okay? When I simplify things, I write equivalent ways of expressing that number, okay? So for this, I'm going to multiply by something. Try to explain this in class here today. I'm going to multiply by something. I want to multiply by this by a number that's going to keep it equal to this. Okay? Because there's one number that when multiplied to any kind of math value, well, it would preserve that value and stay the same. Okay, what number am I talking about here? Okay, what number times by any number, you just get the same, that number is an answer. 1, right? 5 times what is 5? 1. 10 times what is 10? 1, okay? So on all these, right, you want to multiply by a 1 in disguise, okay? I'm just putting the 1 there for now. And if you're paying close attention in class, you know what to do next, okay? And that is multiplying by 1 right here. Okay, we'll keep it the same, but I want to multiply by 1 in disguise. That's also going to get rid of that root 24. Okay, and here's how we do it. Okay, I'm going to go ahead and erase this here. Get rid of the 1. I'm going to multiply by a 1, but it's a 1 in disguise, okay? And it's this, root 24 over root 24. There it is, okay? What's also special about the number 1? Anything divided by itself is equal to 1. There it is. 5 divided by 5 is 1. 10 divided by 10 is 1. Root 24 divided by root 24, well, it's 1. We actually wouldn't have a remainder there. Why? It's called the identity property of division, okay? So anyways, if I do this, it rationalizes the denominator. This is what this means, okay? So I have to multiply my denominators together, right? When you're multiplying a fraction, okay? Might have been a while since you're multiplying fractions, but if I have this, A over B times by C over D, okay, it's not a proportion, it's multiplication in the middle. What that's equal to is A times by C over B times by D, okay? So here I can multiply 24 times root 24, and the pattern we saw earlier is that, well, that's just going to be 24 squared, okay? I still have the radicand above it. 24 times root 24 is root 24 squared. What does a root do to a number, a radicand, when it's getting squared? It cancels the squaring. It cancels it off, okay? So what I end up with here is 24 in my denominator, okay? And then I also, in my numerator, I end up with 12 times by 24, and then that is 288, okay? And that is underneath the radical, okay? So you're doing this problem, and you're doing this here. Guys, are you done? You rationalize the denominator, but is it fully simplified? No, you got to do stuff like this here, okay, with that 288, okay? So let me move this one down here, because we can really simplify this one, okay? So root 288, 2 goes into it 144 times. Ooh, that's a good one, okay? Try some different things out, right? 2 times 144 would bring me to 288. Okay, I still have the 24 in the denominator. Why? Well, I rationalize the denominator. What's significant about 144? Anybody know? You'll learn it soon here. Do 12 squared on your calculator. You get what? You get 144. Yes. There it is. Okay? You can try it out here. You might just get lucky with something like this. And this is might get lucky. If you don't know the square root of 144 is 12. Well, now you do. Check it out. Square root is 12. Okay, so what that means is that I can bust out 12 out of this. Okay, and then this is going to equal 12. Well, root 2, I can't take the square root of root 2. So I just end up with 12 root 2 over 24. And now I have 12 root 2's split 24 ways. Okay, 12 divided by 24. Well, that's a 1-to-2 ratio. Okay, so my answer here is 1 root 2 over 2. Hopefully you see that. Hopefully you got that there. Big numbers right here. Just became that after I worked through it. Okay, this one right here, divide, we got the 1 there. Okay, so I'm not gonna multiply by 1. That's not in disguise. Okay, I'm gonna multiply by 1 in disguise. Root 3 divided by root 3. Okay, because I want to rationalize that down there. Root 3 times root 3 is just, it's 3. Okay, it's 3. So my denominator now becomes 3. My numerator becomes root 15. And can I simplify root 15? Well, 5 and 3 are the only non-1 factors, non-15 factors of 15. Okay, 5 and 3 aren't perfect squares. Okay, so this one actually is done. Oh, it feels so easy after a problem like that just before it. Okay. This one here, it might be actually, there's another way you can do this with these ones here that might save you some time. Okay. And that is instead of multiplying by 1 right now, okay, is that you could actually simplify it. Okay. Simplify your roots. Okay. Simplify the roots here, right? Expand and simplify, that kind of thing here. Okay. So square root of 21, like what goes in 21? Well, 7 and 3. Okay, I can't take the square root of 7, can't take the square root of 3, so that's not that useful. So I'll leave this here, square root of 21. But I can square root something that goes into 18. Okay, what are my factors of 18? One that I can take a square root of. 9 and 2. Okay, so I actually can, start simplifying this here. I get root 21 over 3 root 2. Okay, is that denominator still an irrational number? Well, yeah. It is, okay? Root 2 is that, right? It's a whole bunch of things. So if I just take that irrational number and I multiplied it by, multiplied it by 3, okay, it's still going to be some crazy mumbo jumbo action here, okay? So I do need something to rationalize this, but I don't need to necessarily multiply by 3 root 2 over 3 root 2. What can I multiply by? I can just multiply by root 2 over root 2. It's like little puzzles here, right? Stay organized. Math is great, okay? So then I get up top here, I would get, I'll just put the equal sign. I'm getting messy. Mr. Fortin's getting messy again. Okay, this is root 42, and that can be simplified. It can. Okay, over 3 times 2, which is 6, right? Because root 2 times root 2 is 2, and 3 times 2, that's 6. Okay, yeah, there's kind of a lot on these problems here. Okay, number 16, there's a lot here, right? Why? Well, is root 42 fully simplified? Oh, wait, it is. No, it's not. I think it might be. Hold on. 4 does not go into 42. Okay, 9 does not go into 42. I'm trying to go to the perfect squares. I'm trying to do 16 does not go into 42. Yeah, 25 does not go in. 49 obviously is higher than 42. So yeah, so none of the perfect squares go into 42. So this is my answer. I actually have to simplify that further now. Okay, this one here, root 15, I can't simplify root 15. We've seen that before. Why? 3 and 5 don't have they're not perfect squares. Okay, those are the factors of 15. So on this one here, I'm just going to multiply, just do it. Right? Do the process. Okay, multiply by root 15 over root 15. Okay, I end up with 12 root 15s here over 15. And 12 over 15, I can simplify that fraction, right? 12 over 15. Remember, simplifying fractions, just find some common factors that I can get here. Common factor of 12 and 15 is 3, right? So 12 divided by 3 is 4, and 15 divided by 3 is 5. Okay, so the simplest I can write this is 4 root 15, okay, over 5. There we go, okay? This one here, 3 root, well, 27, what goes into 27? Well, let's try 9 and 3, and that's good. Why? Because 9 is 3 times 3, right? 3 squared, okay? So I can bust this one out. Okay, that's going to move a 3 over here. 3 times by, right? Because the square root of 9 is 3. Okay, so I end up with 3 times 3, which is 9. So 9 root 3 is the appropriate simplification here. Okay. All right, so these get a little more complicated here, right? We square it first. We get 10 over 4. This one's done. That was easy. This one here, 121. What goes into? Oh, it's actually that one. That one's a perfect square also. Okay, it can be benefit to you guys to try on your calculator first. Maybe you get lucky. Okay, and 121. I take the square root. I get 11. Okay, it's helpful to memorize the perfect squares. 1 to 15 is what I generally say. Okay, so 11 squared, right? We should know that off the top of our head eventually. That 121 is 11 squared. Okay. 125 is a perfect cube, but this is a square root symbol. Okay. So you need 5 times 25. So this would be 5 root 5 right here. Okay. All right. Mess with me if you have any questions. It is the end of the school day. It's 3:40. I'm starting to feel a little bit better. I think I'll hopefully be in school tomorrow. Thanks for watching. Thanks for working on simplifying square roots with me. All right. Bye, guys. Bye.